So question 11, and this one's on partial fractions and polynomial division. So it says find the values of the constants a, b and c, and we're told that this fraction here is equal to this. So the first thing we're going to do, 1 plus 11x minus 6x squared, and we're going to multiply out the denominator. So we get x minus 2x squared minus 3 plus 6x equals, so let's write this with the highest power first, so minus 6x squared plus 11x plus 1 over, and then we've got minus 2x squared, then we've got plus 7x, then we've got minus 3. So what we're going to do now, we're going to actually do the polynomial division, so I can actually see that a is going to be 3 because we've got minus 6x squared divided by minus 2x squared is just 3. However, if we do the polynomial division, we'll make this partial fractions part here a little bit easier to do. So, minus 2x squared plus 7x minus 3, and we want something that times us by that to get minus 6x squared. So we can see that that must be 3, and then finishing off the grid, we get 3 times 7x is 21x, then 3 times minus 3 is minus 9. So we don't want 21x though, we want only 11x's. So if we take 10x from that, we get our 11x. Notice we'll put it on the outside of the grid because we've filled all the gaps in the grid now. So we've got a minus 9, but we want a plus 1. So we're going to have to add 10 to the remainder. So the quotient is 3, as predicted, and the remainder is minus 10x plus 10. Therefore, the original function, f of x, is equal to the quotient, 3, plus the remainder over what we were dividing by, so x minus 3, 1 minus 2x. And now we're going to write this bit in partial fractions. So we've got minus 10x plus 10 over x minus 3, 1 minus 2x. We want that to be identical to, and it's told us here, b over x minus 3 plus c over 1 minus 2x. So b over x minus 3 plus c over 1 minus 2x. Multiplying by this denominator here, this implies that minus 10x plus 10 is identical to b 1 minus 2x because the x minus 3's cancel, plus c x take 3. So now subbing in some tactical values of x, so let x equal 1/2. So we'll let x equal 1/2, then this bracket here becomes 0, so x equals 1/2, which implies the left hand side, so minus 5 plus 10 equals c 1/2 minus 3. So that implies that 5 equals minus 2.5 c, which means that c equals minus 2. Now let's sub in x equals 3. So let x equal 3, which implies that minus 30 plus 10 equals b 1 minus, and 2 lots of 3 is 6, which means that minus 20 equals minus 5b, which means that b equals 4. Therefore, f of x equals, well, a was 3, plus, then we've got b over x minus 3, so 4 over x minus 3. Then we've got c, which is minus 2, so take 2 over 1 minus 2x. And there we have it. That's the question answered. There's our answer there. So the next part, part B, so let's clearly label it part B. It says prove that f of x is a decreasing function. Well, the best way to do that is to differentiate it. So first of all, let's write f of x in a differentiable form. So f of x equals 3 plus 4 lots of x minus 3 to the power of minus 1 minus 2 lots of 1 minus 2x to the power of minus 1. So differentiating, we get f dash x equals, well, the 3 disappears. That becomes minus 4 x minus 3 to the minus 2. Then remember, when differentiating with a chain rule, we'll multiply by the differential of what's in the bracket. In this case, it's just 1, so it times by 1, but we'll not bother writing that. Okay, then this here, times by the power, becomes plus 2, 1 minus 2x to the minus 2. But again, chain rule, so we'd multiply by the differential of the bracket, which is minus 2. So that's equal to, and let's write this line back in non-negative index format now. So we've got minus 4 over x minus 3 squared. Then minus 2 times 2 is take 4 over 1 minus 2x squared, which is clearly less than 0, but we should explain why. So, because numerators, let's write that more clear, because numerators are negative and denominators are positive, since squared numbers therefore function is decreasing. Really make sure you conclude here. It asked us to prove that it's a decreasing function, and a proof isn't finished without a conclusion. So if you're in any way unsure about what we've just done, right from the polynomial division here down to the differentiating using the chain rule, have a look at the other videos that I've done on this. So I've done some very introductory videos. Have a look at those, do some of the categorized exam questions, the exam questions by topic that I've done. It really is the best way to revise. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.